Hello Hires, welcome to Higher Chemistry Lesson 2. So, what we're going to do, from every lesson now on, we're going to do a wee starter, and then I'm going to reveal the answer. So what you can do, I'll read the questions out, and then once I've done that, if you pause the video, attempt the questions, and then I'll reveal the answers. Okay, so the very first one, explain why bromine has a smaller covalent radius than potassium. Question 2, arsenic atoms are larger than nitrogen atoms. Explain the difference in atomic size. Okay, so pause the video, attempt the questions, and then I'll go over the answers. Right, very first one. So explain why bromine has a smaller covalent radius. Now, if we look at our periodic table, okay, we can see bromine is there and potassium is there. So you'll notice that they're in the same period. Okay, so we start off by saying as we go along the period. Now, as we're going along the period, what do we do? Remember, you've got to remember your 3 P's. So, protons. Bromine has more protons than potassium. Okay, if bromine's got more protons, what does that mean? Well, it means bromine's got a stronger positive nuclear charge. And then what does that stronger positive nuclear charge do? It pulls the outer electrons closer to the nucleus, and that's why the atomic size of bromine is smaller. Okay, so make sure you have those 3 points. So you're talking about protons, you're talking about the positive nuclear charge, and you're talking about how the nuclear charge pulls the outer electrons closer. Okay, so well done if you got that. Next one, arsenic's larger than nitrogen. Why? Well, again, if I bring out the periodic table, page 7, you'll see nitrogen is there, arsenic is there, so they're in the same group. Okay, so as we go from nitrogen to arsenic, we're going down a group. Now, if we go down a group, what does that mean? It means 2 energy levels are added. Now, that there is so important. Okay, you have to specify how many energy levels are getting added. And again, if we go back to our periodic table, nitrogen, we add 1 energy level, we add 2 energy levels to get to arsenic. So make sure you are specifying just how many energy levels are added. Now after that, it's relatively straightforward. So the inner energy levels create a shielding effect. Again, mention that it's inner energy levels, and that word there, shielding effect. And what does that shielding effect do? It weakens the force of attraction between the nucleus and the outer electrons. Okay, and that's why arsenic has a bigger atomic size. So the key words there being the inner energy levels, they're creating the shielding effect, and then the whole weakens the force of attraction. That's your key points there. So well done if you got that. Right, now our title today, as mentioned in the previous lesson, is Ionic Radii. Okay? Now just a wee sort of pre-note, so make sure you're writing whatever it is I'm writing. So ionic radii involves ions, okay, and you need to be good at working out what charge an ion has, or what electron arrangement an ion has, and you did that in National 5, so I'm not going to go through it in detail, I expect you to know how to get to the answer. Okay? Now, next wee bit, if question mentions ionic radius, radii, so if question mentions ionic radius, always always write out the electron arrangements. Okay, that there is so important. Okay, I can't actually stress that enough. Okay, so always write out the electron arrangements. Again, I'm just going to add a wee bit that might not make sense to you just now, but when we start doing questions, hopefully it will start to. So, if the electron arrangements of the two ions are the same, talk about the three P's. Okay, so that's your protons, your positive nuclear charge, and your pull. Okay? If they are different, what I want you to do, what you have to do, is talk about energy levels. Okay, so talk about energy levels and shielding effect. Okay, so the best way to work through this is just give you a question. Okay, so we'll do a question and we'll do it together. Right, now, let me just check my periodic table. Right, explain why a calcium ion is smaller than a chlorine ion. Okay, now what I'm going to do is I'll give you, this is page 8 of the data booklet, so you can look at it on the screen or you can look at it on your own. If we look at chlorine, okay, chlorine there is 287, calcium there is 2882. So you might think straight away calcium's bigger. However, the question's asking why is the calcium ion smaller? Now remember the key word here is that it's a calcium ion, it's a chlorine ion. Okay, so we're not talking about atoms anymore, we're talking about ions. Now what is our clue? If the question mentions ionic radius or anything to do with ionic radius, so ions or ionic size, whatever, anything like that, write out the electron arrangements. Okay, so if we go for calcium, yeah, calcium has an electron arrangement of 2882. Okay, chlorine has one of 287. So calcium is 2882 and chlorine is 287. Okay, so that's the atoms right there. Now, if we want to do the ions, okay, how does calcium become an ion? Now, it's a metal, so you should know that metals lose electrons, okay? So it's a lot easier for calcium to lose 2 electrons than it is to gain however many, okay? So calcium loses 2 electrons and becomes 2, 8, 8, and that would have a charge of 2+. Now, I expect you to know how to do that, okay? Now, chlorine would gain an electron to become 2, 8, 8, and because it's gained an electron, it has a 2 minus, a Cl minus charge on it. Okay, now what you'll notice is that the electron arrangements are the same. Okay, now if we go back up here, if the electron arrangements of the 2 ions are the same, we talk about the 3 P's. Okay, now because calcium and chlorine aren't in the same period, we can't mention as we go along the period. So just talk about what one has more protons. Okay, and if we go back to our periodic table, yeah, calcium's got an atomic number of 20, so that's got 20 protons. Chlorine has got an atomic number of 17, so that's got 17 protons. So we start off by saying calcium has more protons than chlorine. Okay. Now, what does that mean? It means it creates a stronger positive nuclear charge. Okay? And then what does that nuclear charge do? It pulls outer electrons closer to the nucleus. Okay, so this pulls outer electrons closer to the nucleus. And if it's pulling the electrons closer to the nucleus, calcium ion is smaller. Okay, now that's your answer, that's it. Okay, what you'll notice is we're writing the exact same thing. More protons, stronger positive nuclear charge, the pull of outer electrons. That never changes, that's always the same. Yeah, more protons, stronger positive nuclear charge, and that pulls the outer electrons. We are literally saying the same thing over and over again, but this time, because it's an ion, we've had to draw out the electron arrangement. Okay, and that, to be honest, is the tricky part. Yeah, once you get to there, that wee statement, that's easy. Yeah, it's getting to this point. Okay, so just be careful with that. Right, now let's go for question 2. Explain why the magnesium atom is larger than the magnesium ion. Okay, so again, the question's mentioned ion. Okay, so we need to draw the electron arrangements out. Now, Mg, if we go to our periodic table, has got an electron arrangement 2, 8, 2. Okay, so we write that 2, 8, 2. Now, the magnesium ion, yeah, the ion wants to become stable, so the magnesium loses 2 electrons, and then that becomes 2, 8. And because it's lost 2 electrons, it's now got 2 more protons, so it's got a charge. It's got 2 more protons compared to electrons. It's got a 2 positive charge. Okay? Now, are the electron arrangements the same? No, they're different. And if we go back to here, if they are different, talk about energy levels and the shielding effect. Okay? So they're different. So what do we talk about? So magnesium atom has 1 extra energy level. Okay? And again, it's very important that we specify just how many. Okay, we can see that from our electron arrangement. Magnesium atoms 282, magnesium ions 28. The atom has an extra energy level. Okay, it's got 1 extra energy level. Now, what else do we talk about? We talk about the shielding effect. What causes the shielding effect? The inner energy levels. Okay, so inner energy levels cause a greater shielding effect. And what does that shielding effect do? It weakens the force of attraction between nucleus and outer electrons. Okay, so between nucleus and outer electrons. So obviously the magnesium atom is larger. Okay, so again, this wee sort of couple of bullet points here, that's not changed. We've literally just done the same thing as we did in yesterday's lesson. All we've done extra is we've had to draw out the 2 energy levels. Okay, right, last one. And this here is a trick question that the SQA like to maybe use as a multiple choice question. So what is bigger? Is it a fluorine, helps if I can spell, a fluorine atom or ion? Okay, so again, what we need to draw, because it's mentioned ion, we need to draw out the electron arrangement. So the fluorine atom, again, if you look at our periodic table, you'll see that it's 2, 7. Okay, how does that become stable? Well, it wants to get to 2, 8, so it adds an electron, so it becomes 2, 8, and it's got an F minus charge to that. Okay, now back to a recheck. Are the energy levels the same? No, they're not. Okay, they are different. 2, 7, 2, 8. Okay, but the number of them are the same. So we've got 2 energy levels there, we've got 1, 2 energy levels there. So what you would normally talk about is the protons. Now, what's got more protons? The fluorine or the fluorine atom? Well, none of them. Okay, so well, both have atomic number of 9. So both have 9 protons. Okay, so we can't talk about the number of protons. We can't talk about one having more energy levels. Okay, so because we can't do that, neither is bigger. Okay, and that's a trick question. Doesn't come up very often. I've only seen it in a couple of multiple choice questions, but just be careful, okay, because it's not unlike the SQA to throw a wee spanner into the works. Right, I think that's it. I did say I was going to make this lesson a bit shorter. So what I'm going to do is I'm going to put up some questions for you to try. Now what I'll do, at the end of every week, I'll put up the answers to all the questions. So I'll put up the answers to the questions in last lesson, and I'll put up the answers to the questions here. Okay, so let's go for number one. What has a bigger ionic radii? Okay, and let me choose a good one. Aluminium or sulfur. Okay, I'll leave a wee gap so I can put my answers in. Question 2. I'm going to add to that, sorry. I want you to explain. Okay, so don't just tell me what one's bigger, explain why it's bigger as well. Explain why, again, let me just check my periodic table, why the sodium ion is smaller than the, let me see here, oxygen ion. Okay, so I want you to try these two questions. Okay, give them a go. Send all your work to me through email, and that'll be us. Just a wee reminder, we are on holiday on Monday, and it's an in-service on Tuesday, so I won't see you guys again until Thursday, but I'll be putting homework up so you're kept busy. Right, thank you.